And now, a session on time series. As always, the goal of this is to give some background and get students started down the path of doing analyses. Mainly here, we're going to focus on graphing and just the concept of working with time series. On the libraries you're going to need, I am going to expect you to use GGplot. I'm going to have given you the data sets to work with. We're going to start by creating a graph of population data in the city of Dayton. So go ahead and open that data file that I have given you. You can take a look at it using view like this, Dayton. This is a very small data set, year and population. This is the actual human population size that I have gathered from census data. This is just an example of a kind of time series. In biology, oftentimes you will have time as one of the axes in your analysis, the x-axis in particular. In this case, we'll start out by just drawing a simple graph. This is GGplot. Dayton is what I named the data set. It's going to come in as Dayton underscore population if you pull it in using the import command. You'll have to change that here, of course. GGplot Dayton aesthetic element X year Y population, and we're going to put a line and a point on this at the same time. This is what it looks like. So pause the video, type the code. Okay, got it. So this is simply x-axis, see my cursor down here? X-axis year, and this is just like, it's a year. And y-axis is population, that's the human population in the city of Dayton, Ohio. Through time, we just start here, I don't know what year this is, 1800 or something, 1850 or something, 1890, let's see, yeah. In any case, taking circa 1950-ish, around 260,000 people, and then a very steep decline following that. I don't have the 2020 data added to this yet. Now, the point of this is a time series is any analysis where X is the time, so something's changing through time, and Y is some variable of interest, in this case, population. Here is a nicer version of this graph. I'll throw it up here for you to take a look at. I've taken out the background using theme classic here. I've also added a border using this theme panel.border black and added GG title Dayton population. So pause the video, type the code, run the code. I'll play some beats for you. Not sure if you could hear that, but yeah. So this is a bit nicer graph. Now I wanted to show you even nicer graph, and in this case, I'm also going to teach you how to export the file. This is a really nice little trick that I learned quite a while back. I think I learned this before RStudio was even a thing. There's many ways to export graphs, but this is one of them. So first of all, let's just go ahead and type this code in here. This is going to be a better version of the same graph. I did this little segment command here because I just think, and this is a graph I made for some small grant I wrote a while back. I just thought this made it a little bit more aesthetically pleasing, and also got your eye to focus down here, because in fact earlier when I graphed this I was confused at what the first point was. Now I know it's 1900. That's this segment command right here, And geom_point is what I had before. Geom_line is right here. The top part is the same. I also modified the scale using scale x continuous breaks, and then you can set the sequence up whatever you want it to be. This is 1900 to 1910, and you say by 10, and that breaks the x-axis up into the specific years. Then I added a GG title, of course, and then I did theme classic and panel border that draws this border around. So here's the code. Leave this alone for now. I'll come back to that. So just pause the video, type code. Okay, got it. Now here's a sweet little trick. You can use this command tiff. Tiff is a kind of image type. Of course, you can export your file using this, export or any number of ways, save as PDF, save as image, copy to clipboard. You can snip it. I use snip a lot just if I'm throwing something in a document or in a email or something. But if it's time for you to like get a graph ready to submit it to a journal, then you're going to have to upgrade the quality of the image. Usually the resolution is required like 300 DPI or something like that. At least that's what I've got here, or more, 500 or 750 or something, to make it a sharper and sharper and sharper image. And figuring out how to get that done is not obvious until you watch this video. And now it is obvious, which is using a tiff command. So the way this works is tiff file equals, and this is the path you want the file to take, where you want it to go, basically. Not basically, where you want it to go. And you got to be specific about this. In this case, I'm going C:/ user/ Ryan McEwan 1. That's just my like UD. I work at the University of Dayton. It's just like what I have to log in using. Desktop is the desktop of my computer. I pick this, which is the name. This is where R will send the file. Now, if you get confused by this, you can just go to like, here's an image on my desktop. You can see it right there. This is a burrow seedling. Very nice picture. And you're like, okay, I want the image to go there. The way to do it is I'm going to right click here and go down to properties. And then in properties, you can see right here is the pathway. You see that? That's the file properties. It's confusing. Once you have that, you can copy it actually and paste it into RStudio if you like. The only thing is, for reasons I don't understand, some data science person knows, these slashes are the wrong way out here. Someone will tell me why that is. They're slashing this way here. In R, you have to slash them forward. No idea why. Okay, then you go, how tall, this is in inches. I say the units here. How tall you want it to be. This is 5 inches or 5 inches wide, 5 inches tall. Inches is the unit IN. We're comma here, comma here, comma here. And then resolution is how many dots per inch, DPI. And that's just like how sharp the image is going to be. So you can choose that. 300 is very sharp, and you can go like 750 or 1,000. It makes a very big file though. So you don't want to do this if you're just like jamming your data, but you would do it if you like, oh, I want to submit this to a journal. Or submit it, for your master's thesis or something like that. And then, so you're going to make a sandwich out of the code. This is like your graph code. This goes the bread on the top. And on the bottom, you put this DEV.OFF, open and close parentheses. If you don't do that, it's going to freak out. By the way, notice we did an open and close parentheses around the tiff command as well. And I just have these commas here. Don't miss those. Comma, comma, comma. And then the space between the actual graph code and the tiff command, and also another space here. I don't know if you have to have those spaces, but that's what I do. So once you got that done, you highlight all of this now, including the bread and also the lettuce here, or whatever is in the middle of your sandwich, and hummus and shredded carrots. And then you run that. Now it doesn't appear over here because it's going, oh, you want me to make a tiff file. Where did it go? You should know the answer to that is what you told it right here. If you don't get this right, it's going to probably give you an angry, like a rashy, like you messed up. Down here, if you do successfully complete this, then it's going to appear. We have to go to where I sent it. We'll have to go find it out here. Oh, here it is. Ready? So I told it to go to my desktop. Here's all random things on my desktop. There it is. So now we've got a nice high DPI quality image. You can change the size of it. It looks a little bit boxy here. I might make it a little bit shorter. And like, it looks a little too boxy for me. So let's do something else here. Let's make the height fuller. Let's run it again. And if you run it again, it's just going to overwrite what we just did. I'm going to save because I'm adding some code. Go back out. A little bit nicer there. You can manipulate it this way if you'd like. And now you have an image on the top of your desktop or wherever you decided to send it. And it's going to be a large file. This is 5.14. So, more DPIs, the higher quality of the image, the more, the larger the file. That's all. So, type this code, run the code, create a TIFF file on your desktop. Oops. Okay. I'm a little worried that the drumming is not working, so maybe we should stop that. Okay, next is a phenology data set. I won't do the TIFF part of this. This is just like, that was just like a little tip for you. But this is a probably more typical kind of time series. So I'll give you a second to read the data in. I, of course, always do the read.csv command because it works every time. And I don't have to worry, I don't have to think about it doing these little buttons over here. And plus, I grew up using just the regular R console, so this is just natural for me to do it this way. You can take a look. Yeah, you can take a look at the file like this once you have it loaded. I'll give you a second to take care of that. Okay. So pause the video, run the code. You've got the data set in now. And this is complicated, and I can't go through it and explain to you everything that I've done here. All I'm going to say, and you'll understand it better once we look at the graph, but we have observations. This is an ecology data set. This is an observations on different days of different species, or 3 different species here. Score is the kind of observation that we made. There's a scale. It doesn't matter for the purposes of this little exercise. And actually, we're taking the average on that date for this individual. So this is actually the average, and we had multiple different, I think there were 5 stems or something, and so it would be the average of those 5. And then we also calculated a standard deviation of that average. So you had 5 observations, you take an average, and you can calculate the standard deviation. How to do that is a separate topic. I'm not going to do that on this short video. It's not very hard a thing to do, but it is essential for this kind of graph we're going to make. Okay. So we're going to need you to have that standard deviation or standard error. Then you've got the mean. You've got all these observations. This is quite common in biology. For example, oh, I've got these petri dishes. I've got 5 petri dishes. I've got a bacteria growing in there. We're going to treat them with something, and then we're going to wait 2 weeks and measure them every day for 2 weeks. And we'll have something like that, or whatever, or like the mouse, or whatever. So you're measuring multiple experimental units on multiple days over time. This is normal standard operating procedure in a lot of biology experiments. And you go, okay, well, now what do I do? And one thing you want to do is create a graph, which I'll talk to you about now. I will say also that once you have that kind of design, you're going to need to deal with time in your analysis. There's different ways of handling that. Something called a repeated measures ANOVA is like a classical way to do it. You can have time as a fixed effect or whatever in a mixed model. There's going to be some way you're going to have to deal with it, and I can't tell you what to do right now. It depends on the details of the design. But you can't just go like, oh, I did this thing where I've repeatedly measured something and I haven't accounted for that. You've got to account for it some way in your ultimate model before you move forward in your analysis. So if that's the case, stop and think before you proceed. For now, I'm just simply going to give you a bit of discussion and show you how to graph something like this. Okay, this is a bit of a complicated, it's not that complicated, but here's the code to create a graph. It's not that complicated, but it I think quite helpful. So will be helpful for most people. And I'll go line by line and discuss what we've done here. For now, pause the video and type the code. Ready? Okay, so we're going to go GGplot, obviously, data file name, which is Spring CSV. Again, I did this read, so anyway. Yep, static element. I'm calling X date, Y score, because we go back to this and we go, well, we've got score and we've got date. We're graphing over date. Score through 3 different dates. Color, species, group, species, shape, species. You need all 3 of those in this first part of the code. Again, comma here, comma here, comma here. There's no need for them to be tabbed like this. You could stretch that out, but I tab because it makes it easier for my eyes to find out where we're at. Then geom line and geom point. We need both of those. And then here I'm adding, that's these points and the lines right here. And then I added this geom error bar, that bit of code. So this is these error bars. See my cursor right here? This like little, like the wings of the TIE fighter here. And you need, first of all, you have to have this done. The standard deviation has to be in the data set. There's no way that I'm aware of that you can calculate have GGplot instantaneously calculate that for you. You have to calculate it in a separate step of coding and have it here in your data set. Again, I am not going to explain how to do that right now. It's a separate topic. It's not that difficult. So you're going to have X as a date. That's this way. See my cursor down here. You got Y min and Y max, because now we're describing the error bars. We want to describe how tall the error bar should be. And what we're doing is score, which is this, see our y-axis, minus, this is going to be minus 1 SD, score on the y-axis here, plus 1 SD. So that's going to give us the down part of this bar and the up part of this bar. Alpha is just making it transparent so we can see through, because we start to overlap here. See this in this part right here. I think, and you can play with that. You know, whether you three is just a random. You know, you can pick whatever one you want and tinker with it. And if they're not overlapping anywhere, you might not care, but you don't want to necessarily cover up your points with error bars. And then width is the width of this thing here, like the TIE fighter wing. You can make it wider or narrower, depending on what you want to do. So this is like this is like customization. And this is the size, and it's plus or minus 1 standard deviation right here. You could, of course, use 1 standard error instead. You just have to have standard error here. See that? I tabbed over back to the data slide. And you can calculate that also. It's not hard. It's easy to do. Right. So you just call SE or SD here, and all this geom error bar little command here is doing is going and looking in there and going, okay, SD, and you want to go plus or minus 0 or plus or minus 0.45, and symmetrical is plus or minus the standard deviation. That's how that works. And then the rest of this is just plus theme classic. This is customizing the graph because I just didn't want the gray hatching behind here. It makes it hard to read. Theme axis x. Okay, look at this one a little closer. Axis.x element underscore text equals angle 90. That's this. Because these were long dates, I just adjusted those so they will go straight up and down. So you can play with this a little bit if you want. And you can adjust their height as well. This is horizontal and vertical adjustments. You can play with it, tinker around a little bit to customize it. And then I put this legend, see this? It will be over on the right side, and it would sort of squash your graph. And I think for the purposes of like if you're writing a journal article or something for your thesis, you want that to be in the plotting space sometimes. Not always, sometimes. You can move this around wherever you want. So you can just like type this code in, get this thing, and then tinker with it. I would encourage you to play around its position. You can move it around where you want. And obviously you may have a graph where it's going up, and you might want to put it like on the bottom part, on the bottom right, or wherever you want to put it. You can adjust it that way. So this is a pretty nice model graph for a repeated measures or time series kind of analysis that would be really common in biology. You might have 3 different treatments of antibiotic 1, antibiotic 2 control or something, and you've got 5 petri dishes, or there's many different things that you could be doing where you'd want to have a graph like this. And I just think this is a good model. Obviously, have fun and explore your own way of graphing this. And you can, of course, decide to manually pick the colors. You can manually pick the shapes. You can customize, as we always do in GGplot. That concludes my session on time series. It wasn't a lot, but hopefully it can give you a start heading down that path. So thanks, and we'll see you next time.